So this is one final thing that can be done with both of these two equations right here. You can actually determine the molar mass of something from these equations. This was done in the gas chapter, and so if you kind of remember it from the gas chapter, you might be able to catch on really fast on this. The reason we can do this is that our molarity term, it's a moles per our volume times RT. So we can solve for moles. If we're given grams in the problem, the molar mass just becomes our grams number divided by our moles number. It happens in this lower one also. So again, we've got the KB, the molality, it's moles, which is in, and then this is your mass, and this would have to be in kilograms of your solvent. So again, if you solve for N, and if the mass were 5.0, you could say 5.0 grams per N, and when you solve that, you'll get your final calculation. So you'd have to be given all the different numbers in the problem to make it work. I'm going to go ahead and just rearrange it really quickly. So I'm getting pi times V over RT equals N, and I'm just going to plug these numbers in. So I've got 9.4 times 0.5, that's my volume, over my R, which is 0.0821, times my temperature, which is the 298.15. That'll get my N value right there. I'm going to go ahead and plug in this other one. I'm just kind of doing it rearranged. So my N is equal to, I'm going to pull the mass in kilograms of solvent over to the other side. Mass, kilograms, solvent. I don't have a good way to represent that. And the whole thing's going to be divided by KB. So my delta T, if it were 2 degrees Celsius, if my mass of my solvent was 1 kilogram, and if my KB value, I've got a lot of sounds, was 0.512, and note the units on this is molality time per kilogram, so that's what helps cancel out our kilogram. I'm sorry, it's degrees Celsius. No, it is. It's molality, degrees Celsius per molality, sorry. And there's a kilogram term in the molality that cancels it. And regardless, when I fill that out, I will get a number right here. So I'm going to go ahead and solve both of those. The top one is 9.4 times 0.5 divided by 0.0821 divided by 298.15. Whoops. Left a zero at 0.15. So that number gives me 0.192. I could round it to just the 2 sig figs, 0.19 moles. And over here, 2 times 1 divided by 0.512 gives me 3.9. I'm going to scooch this over so I've got the space. This is just the 1 sig fig, so I guess I could say 4 degrees. 4 is my moles. And then again, because the problem also gave me my mass, I just take my 5 grams and I divide by my moles that were given. And in this case, my 5 grams divided by my 4 moles. And that's going to be the molar mass of the substance. So the top one, 5 divided by 0.19, gives me 26 grams per mole. And then the bottom one, 5.0 divided by 4, it's 1.25 grams per mole. So I guess I could have picked that one's numbers a little better. I just kind of made these ones up. But I'm just trying to demonstrate that you can actually get molar masses from these equations. So it's one of those things where you can, if you don't know the molar mass of something, but you know it's a liquid and you know its concentration, if you know all these other variables, you can back solve for molar mass.